we are still doing tutorial 2, of course, and we are completing quiz 4. So we have already completed quiz 4 for section 10, and this time we are doing the problem for section 20. So this was the problem, and until here the solution was there, that you see you have to find for cobalt oxide on the 1 plane. So we have drawn the plane and we have counted the number of anions. So this is very critical, right? In your solution you cannot just write 2 anions. You show this exactly. So, and this is required also, that show this on the diagram. And once you have shown this and you write this, then we know that your knowledge that on this plane there are 2 equivalent anions is very correct. So because you see, why are we doing this? It is planar density. Planar density is number of atoms on the plane divided by the area of the plane. So number of ions on the plane, is this, and then for this plane you find the area of the plane. So I am showing you the rest of it. For this type of ceramic, remember that A is equal to 2R plus R. This was the basic thing, that A is equal to 2R plus R. So you put the value of R and R for the 2 ions, it is given, and therefore it is 0.428 nanometer and so on, right? So this is directly there. This that what is the area of this triangle? Area of any triangle is half base into height. Half base. Base is this. So base is very simple. If this is A and this is A, then this base is root 2A, right? So half into base is root 2A. And remember that we exactly solved that this height exactly solved in a solved problem in the class will be equal to root 3 by 2A. So this is it, that root 3 by 2 A square or whatever. So this, and now you have already found the value of A, so you put it there, and this is nanometer square. So this is the area. And by definition, planar density is the number of ions divided by the area of the plane. So equivalent 2 were there and the area is this. So 12.6 ions per nanometer square. 12.6 ions per nanometer square. This is the unit. We do not need to change here to any centimeter, meter and so on. Some of you did it, so that was useless, right? You don't need to do it, because planar density is not like a standard density. Volume density, standard density is gram per cubic centimeter or kilogram per meter cube. But planar density is number of ions per nanometer square directly. So don't complicate, don't waste time. So this is it. Now this if this was oxygen, then this is for oxygen ions. Now we have to write the same answer for the cobalt ion. This is cobalt oxide, right? So either we do the calculation again, or we simply write this, that you see in cobalt oxide it is 1:1 ratio, 1 cobalt to 1 oxygen, 1:1 ratio, right? So therefore the planar density for cobalt ions will also be the same. So this is the reasoning, and we told you in the class also that if it is 1:1, and of course in any unit cell both the materials have to be balanced. The anion and the cation have to be balanced. Whatever amount of one is there, exactly the same amount of the other will be there, so that the chemical stability is there, +1 -1. So therefore this is the final answer, that for cobalt oxide the planar density is 12.6 either cobalt or oxygen ions per nanometer square, right? So again, I mean, these were simple questions, and I'm repeating myself, they were especially more simple, they were simpler for you because you were revising only 1 chapter. If you are revising 2 or 3 chapters at the same time, then your mind is taken up by other things also. So this was a very simple one, but this is how it was, and that is why most of you will feel that you did generally better in quiz 4 than in previous quizzes. So with that, quiz 4 is finished. We have done question 1, which was the multiple choice and so on, and we have done question 2 for both section 10 and section 20. And with that, it is the end of the tutorial. Tutorial 2, as I said, is the pre-final exam tutorial. So it was a long one in different pieces that we did for you in the videos. Full solution of the midterm, full solution of quiz 3, and full solution of quiz 4. So now you have hopefully more practice before you go into the final exams. You know the exact course and so on. The only thing remaining is a little bit of practice and so on. So all the best for your final exam. And what I repeat always, that in all the chapters that are covered now in the final exams, we have already removed some of the chapters, so the final exam is smaller than it could be. So for all the chapters that are covered, covered means covered in the lecture notes and covered in the classes. So all of you should concentrate very quickly, go through the chapter and so on for multiple choice and so on. But for the numerical part, the small theory part, all the examples that we solved during the class, many of them were very good examples. Solve them again, hide the solution, solve them again. All the problems given in the homeworks, you have already submitted the homeworks and so on, are very good problems for practice. But whether you solved the homework yourself or took it from somebody, now is the time to solve the homework problems again yourself, totally independently, right? Hide the solution, solve it again, get a good practice. And one thing more, that the final will include labs also. So you have done the labs, you have submitted the lab reports, but quickly go through your lab reports and so on, so that if I ask any questions from your labs, then you are ready for that. And my guarantee, as before, if all the example problems that we did throughout the semester in the class, if you can do that independently, and if you can independently solve all the homework problems, you are already above average in the class. And for those of you who want A level, A minus grade or A plus grade, then apart from the class examples and the homeworks, go to the end of the chapter, in each chapter, and find one or two problems only, one or two problems which you feel are very difficult. Don't do every small problem. You can finish every problem if you like, but if you want to save time, then go to the end of the chapter problems, select only one or two or three more difficult problems, and if you can solve those difficult problems with surety, then you are very, very well prepared. And of course, from now on until the exam time, if you are confused anywhere, if you think some concept is not very clear, you can come to my office. If you don't find me, you can drop me an email and we can discuss which area you want to review with me again, right? So once again, it was very nice having you here during the semester, and I hope that I conveyed to you the main idea that materials science and materials engineering is one of the major backbones of engineering, whatever type of engineering you are doing. And this was a good general introduction to material science and engineering, and hopefully you have learnt quite well, and especially after revising for the finals, you will be a much better student of material science and engineering, right? And hopefully you will get a pretty good grade also. So again, all the best in your final exams and in your general life. Thank you and ma'as salama.